Hello, nice to meet you. My name is Sakura Tomita. Today I'm going to talk about my recent progress. My study theme is a little bit changed. My new theme is research about the method of evaluating the oyster internal quality. And this is the content of my presentation. First, I'm going to talk about background, and next, objective, method, experiment, and then finally, I'm going to talk about my next plan. Then, let's start with the background. As you know, oyster is a very popular food around the world. We can eat them everywhere in the world, Asia, Europe, and America. And the oyster's special point is its great deal of nutrition. It contains many varieties of nutrition such as zinc, iron, vitamin, and so on. And their farming started in Europe in 1 century before Christ. And nowadays, they are mainly produced in Asia, America, and France. This is the world oyster production researched by the FAO in 2010. The China's occupation is very high, but Japan ranked in 2. And the oyster's special characteristic is its shape. The shape of them is very irregularly. The mature shape and size of an oyster depends on the environment surrounding themselves, and also depends on the type of bottom to which they are attached. So, because the shell's size and shape is various, here some problem occurred within the customers and the sellers, because as you can see from the picture, there are sometimes oysters whose meat volume is not proportional to the volume of the shell. So sometimes there is a oyster with large shell, but only small meat inside. Because there's no technique to know the internal quality of oyster, we cannot know the volume of meat until we open the shell. So our objective is to develop a method to measure the volume of meat in the shell without killing the oyster. This technique will surely be a help to guarantee the quality and also avoid customers' complaint. And there's a possibility of oyster branding. Then I will explain about our idea of how to measure the meat volume. In our research, we use these 4 parameters. 1 is the density of shell, and 2 is the density of meat, and 3 is the total mass of shell plus meat, and the 4 is the total volume of shell plus meat. By using these 4 parameters, we can solve this simultaneous equation. The red font is the 4 parameters, and the black font is the target value we want to know. By using the up 4 parameters, we can solve this equation and we can get the answer. So we can get the volume of shell and the volume of meat. And this is the plan of measuring. First, the mass of shell plus meat can be measured by using the scale easily. And the volume of shell plus meat we think it can be measured by using Helmholtz resonance. Because the Helmholtz resonance is acoustic resonance measurement method, which can detect the correlation between volume and the resonant frequency. And the density of meat and the density of shell, we are planning to use each average value. So, to satisfy the previous simultaneous equation, we have to check these three important points. First is if we can remove the water exists inside the shell. And the second is if there should be a small individual variability in density of shell and density of meat. And finally, we have to check if the volume of shell plus meat can be estimated by Helmholtz resonance. Then I check those 1 and 2 points by some basic experiment. I use 15 giant Pacific oyster for the sample. The size is from 15 to 250 grams. And then first I check the component proportion of oyster. Here I showed us 3 examples. As you can see, in the oyster there's a shell and water and meat, but those proportion is very random at each individual. So, in other words, it is impossible to predict each water amount. In this study, water is just the obstacle, so we have to remove the water from the oyster, the shell. So we try some method to remove water from the oyster, and we found this centrifuge separation was the best way to remove water from the oyster. Maybe you can understand easy. Just cut the tips of the oyster a little and put into the socks and swing. So swing 150 times. But the result is great. The removal ratio is from 82% to 96.3%. It's very high. The average of 15 sample is up to 89.5%. This is the highest removal ratio which we tried ever. So we decide this. We use this method to remove water. And then next, I also check the individual variability of the density of meat and the density of shell. I check the deviation of those values. As you know, the density can be calculated by this equation, mass divided volume. So, as the mass, we can measure by using scale, and when we measure volume, we use the water immersion method. Then the density result become like this. The density of the shell, the average density of shell is 1.81, and the average density of meat become 1.05. But the most important point is the deviation of each value. The deviation of density of shell is much bigger than that of meat. So we decide that at the density of meat, we will use the average value, 1.05. But at the density of the shell, we have to estimate from other value somehow. And finally, we found that there's a high correlation between density of shell and the density of shell plus meat. This is the graph. X-axis shows the density of shell plus meat, and y-axis shows the density of shell. There's a high correlation. R square equals 0.837. So, but this density of shell plus meat can be calculated by the mass shell plus meat divided volume shell plus meat. So, if we can know the volume of shell plus meat accurately, we can know the density of shell by using this equation. So, then I finally explain my next plan. This is the progress. We to know the volume of meat, we have to know the 4 parameters. And in 4 parameters, this depends. The density of shell can be estimated from the density of shell plus meat, as I explained before. But the volume of shell plus meat has to be estimated from the Helmholtz resonance result, from the resonant frequency. So next plan, I check the calibration curve between volume of shell plus meat and the frequency and the resonant frequency. Thank you. That's all. Thank you.
Question? I think you'd better use some turntable rotating the high speed.
Oh.
This way is not scientific.
Basic experiment. I have to make.
Not consistent after 30 minutes, maybe slower.
I suggest you that the equation about 7, that equation is very important to make us understand. And then hopefully don't erase that what's mass, what's something together. A little bit show and understand.
In your introduction, you said that you wanted to do it non-destructively. So if you now you can cut it open and you can measure. But cutting the end off and taking out the water is not going to keep the freshness of the oyster.
But no problem.
No problem.
The aquaculture man said to me, only cut a little or only penetrate a hole on the shell. It's okay. Oyster is very strong, they can they can live without water for 10 days. And so after cut and remove water and measure, and as soon as after measure put into the salt water is enough, maybe keep the freshness.
Then create another shell.
Maybe no, because they if they want to grow, they have to get attached to somewhere. After
harvesting, just some waterfall, no way. But if throw those oysters into the ocean, the sea, they may create their shell again by themselves. To cure that part of the cut part. That's my curiosity.
Yeah, the title says the internal quality. Actually, you just measure the portion of meat.
Yeah.
Is that internal quality is only that?
Delicious oyster is 生殖層ってなんて受精構成ってなんて
That is a difficult one.
抱卵ってなんて
Eggs.
After oyster is
some organ to make eggs or some sperm would be good or not?
As soon as after remove the eggs from themselves, the oyster is not delicious. It's very included in internal quality. But if we want to know it, we have to check the color of the meat. But maybe we can't see the color. Color is different between delicious oyster and not delicious oyster.
Yeah, if there is other parameter that describing the internal quality of the oyster, maybe you need to change the title, maybe to measure the meat part or something like that.
Okay.
You talk about internal quality, inside is only measuring the meat part of the oyster.
Okay, thank you.
Could you show us the photos again, the internal meat? Another one, which one is the biggest? Center one?
Maybe center one.
Then next to be the lightest. Then left. No concern with the shell size.
The price is decided by the weight or
weight of the whole shell.
So maybe those three is same.
So customers may buy the shell, big shell, but small meat.
Yeah, of course, complain.
When cut this part,
Yes.
this is the opposite.
Yes.
Upside down. Okay, cut here. This one might be cut meat too. No. No. Okay.
This part is
Any other suggestion? Comment? Okay, thank you very much.
Thank you.